Okay, friends, so here is a question on rigid body motion. Let's see how we can solve this particular. So, a uniform circular disc is there whose mass is 50 kg and the radius is also given. Okay, it is rotating with an angular velocity of 10 radians per second, okay, about its own axis, which is vertical. Okay, so disk is horizontal, so that is why the axis is vertical. Two uniform circular rings, each of mass 6.25 and radius zero point 0.2 meter, are gently placed symmetrically on the disk in such a manner that they are touching each other along the axis of the disk, okay, and are horizontal. Assume that the friction is large enough such that the ring are at rest relative to the disk. You need to find out the new angular velocity of the system. Okay, now clearly this is the case of conservation of angular momentum. Okay, but then at times students are in a hurry and they don't pay attention to detail, and that is why you will arrive at the wrong answer. Okay, so if you pay attention carefully, you will see that what this situation is, that two rings are of radius zero point 0.2 meter. They are touching each other on the axis. So this is how the two rings are placed. This is one ring and here is another ring. Okay, the disk is of radius zero point 0.4 meter. That is why the rings can be arranged like this and they touch here. All right, so this is the situation, and clearly we can apply conservation of angular momentum about the axis. Okay, so before these rings were placed, the angular momentum was what? M r square by 2, which is I times omega. Okay, now after the rings are placed, let us say that the new moment of inertia is I, so I times omega 1. Okay, so initial angular momentum is equal to final angular momentum. Now what is I is a new moment of inertia, which is nothing but moment of inertia of the disk plus moment of inertia of the ring about this point. Let us say that is point P and this is O. Okay, now moment of inertia about O is m into r square. Okay, this is the ring's moment of inertia. Plus you need to move this axis from here to point P. Okay, so plus mr square. So this is the moment of inertia of one of the rings, but there are two rings, so this into 2. Okay, the total moment of inertia you will get as capital mr square by 2 plus 2 times small m into small r square. Okay, so I can just substitute the values, and there is a relation between capital R and small r. So basically small r is capital R by 2, isn't it? The capital R is zero point 0.4 and small r is zero point 0.2. So just for the simplicity's sake, I will write in terms of capital R. So this will come out to be m r square by 2. Fine. So now let me substitute the values. So m r square by 2 into omega is equal to capital M r square by 2 plus small m r square by 2 into omega 1. Okay, you can see that r square can get cancelled, even the 2 will get cancelled. So you will get omega 1 to be equal to capital M divided by capital M plus small m times omega. Fine. Now capital M is what? 50 kgs. Okay, so 50 divided by 50 plus 6.25 into omega, that is 10. Okay, so this is new angular velocity, right? So let me simplify this further. So this will be 50 divided by 56.25 into 10. Okay, so this one is new angular velocity. There is a small mistake here. Actually, mr square plus mr square into 2, this will give you 4 mr square. Okay, so and small r is capital R by 2, so this is just mr square. Fine. So when you substitute all that, this will come out to be this into 2. Okay, and you will get, you'll get 50 plus 6.25 into 2. Okay, which is nothing but 62.5. All right, which is zero point 0.8 into 10, and hence you will get the value as 8 radians per second as the answer. Okay, so that's how you have to solve this particular question. Here, I myself have made a calculation error. So at times, the mistake you do is not related to physics, but related to calculations. And, in your experience itself, you might have seen that most of the time it is non-physics mistakes that we do. All right, so make sure that you don't you should be very careful that you should not do mistakes on things which you know. Okay, so that's how you have to solve this particular question.